welcome to Chapter 2, Observing the Sky, the Birth of Astronomy. In this chapter, we will get more into the history of astronomical discoveries and important astronomers. Our first section of this chapter is the sky above. Before the Earth was flooded with man-made light, people could more easily see the stars and the planets. Whether it was to navigate, tell time, or a part of their religion, all ancient cultures used the stars for some purpose. In remote locations today, like the desert, we are able to easily observe the stars like ancient peoples. This is a photograph of the night sky without the interference of human light. These ancient peoples generally agreed that the Earth was the center of the universe. This is a geocentric view of the universe. The geocentric perspective reinforced the philosophical and religious systems that taught the unique role of human beings as the central focus of the cosmos. Gazing up, you get the impression that the sky is a great hollow dome with you at the center, and all the stars are an equal distance from you on the surface of the dome. The top of that dome, the point directly above your head, is called the zenith, and where that dome meets the Earth is called the horizon. Ancient people laid and watched the night sky for hours. Purely from these observations, it appears as though the sky is a dome which turns around you, bringing different stars into your view. The ancient Greeks believed the sky to be the celestial sphere. To us, even objects that do move seem stationary with respect to the other lights in the sky. Everything seems to move together instead of independently. To help us orient the turning sky, we use the celestial sphere and aspects of Earth in order to label the celestial sphere. There are celestial poles and equators. This photo is taken at the South Celestial Pole. It shows how the stars seem to move around us, even though we are the one rotating. Sunlight scatters light through the molecules from the atmosphere, hiding the stars. They still continue to move on the celestial sphere, but we cannot see them. After a year, when the Earth has completed one trip around the sun will appear to have completed one circuit of the sky along the ecliptic. Because of its motion on the ecliptic, the sun rises about 4 minutes later each day with respect to the stars. Earth must make just a bit more than one complete rotation with respect to the stars to bring the sun up again. The view from different latitudes makes the turning of the heavens look different. For example, at the North Pole there is no rising and setting. At intermediate latitudes, stars rise and set at an angle which is equal to the observer's latitude. As Earth revolves around the sun, we sit on platform Earth and see the sun moving around the sky. The circles in the sky that the sun appears to make around us in the course of a year is called the ecliptic. This circle, like all circles in the sky, goes through a set of constellations. The ancients thought these constellations, which the sun and the moon and the planets visited, must be special and incorporated them into their system of astrology. Note that from any given time of the year, some of the constellations crossed by the ecliptic are visible in the night sky. Others are in the day, and thus hidden by the brilliance of the sun. The celestial equator is tilted by 23.5 degrees to the ecliptic. As a result, North Americans and Europeans see the sun north of the celestial equator, and high in our sky in June, and south of the celestial equator, and low in the sky in December. Ancient people saw that there are stars that seem to move with respect to the stationary stars in the sky. They called these wandering stars. What they saw moving was actually the planets. The word planet means wanderer in Greek. The wandering stars were each dedicated a week. The moon takes 1 month to move across the sphere. We can calculate this using physics. Speed is the distance over time. This equation is true with any units as long as we are consistent with them. Let's say you notice a bright star Sirius due south from your observing location in the northern hemisphere. You note the time, and later, you note the time that Sirius sets below the horizon. You find that Sirius has traveled an angular distance of about 75 degrees in 5 hours. About how many hours will it take Sirius to return to its original location? The speed of Sirius is 75 degrees over 5 hours. This simplifies to 15 degrees per hour. We can isolate time in our speed equation to write it as distance over speed. We know that a complete rotation is 360 degrees. So time is this 360 degrees over 15 degrees per hour. This simplifies to 24 hours, which is how long it takes for a complete rotation of Sirius in the sky. The moons and planets all lie in the same plane, so they all lie within 18 degrees on the ecliptic. This is also where all the zodiacs lie. The zodiacs are always there, but half of them are drowned out by the scattering of sunlight. Constellations are ways that the ancients grouped the thousands of stars visible to the naked eye. Many cultures named the pictures they saw in the sky. The constellations helped them navigate the world. Orion is an example of a famous constellation. Students are sometimes puzzled because the constellations seldom resemble the people or animals for which they were named. In all likelihood, the Greeks themselves did not name the groupings of stars because they looked like actual people or subjects, any more than the outline of Washington State resembles George Washington. Rather, they named the sections of the sky in order to honor the characters and their mythology, and then fit the star configurations to the animals and people as best they could. We have modern-day systems for organizing the sky. Today, a constellation refers to one of the 88 sectors we have divided the sky into. Not all constellations are the same size. The modern boundaries between the constellations are imaginary lines in the sky running north, south, and east and west, so that each point in the sky falls in a specific constellation. We named each modern constellation after the Latin translations of the ancient Greek star patterns it encompasses. We also use an important word, asterism, to denote an especially notable star pattern within a star pattern or several star patterns. For example, the Big Dipper is an asterism within the constellation of Ursa Major and the Big Bear. Our next section is on ancient astronomy. Ancient Babylonian, Assyrian, and Egyptian astronomers knew the approximate length of the year by keeping track of the stars. The ancient Chinese recorded meteors as well as bright and dark spots on the sun. They kept track of the stars that could barely be seen and then suddenly flared up. We still use some of these records in modern astronomy. The Mayans developed a sophisticated calendar based on Venus. The ancient Polynesians navigated the ocean using stars. Ancient people in Britain would keep track of the sun and moon with great stone circles called the Stonehenge. Cosmology originated with the ancient Greeks. As we've discussed, cosmology is concerned with the past and future of the universe. Many ancient peoples believed the Earth to be a perfect sphere. Mostly this was for religious reasons, since we are perfect forms. We cannot discuss ancient astronomy and leave out Aristotle. His writings summarize many of the beliefs held at the time. He discusses the moon's phases, its changing shape, and evidences solar eclipses, proving the sun to be further than the moon. He cited the Earth's shadows on the moon as evidence of the Earth being round. If it was a disk, the shadow would sometimes be a line. A lunar eclipse occurs when the moon moves in and out of the Earth's shadow, which is curved. Aristotle also noted that the position of the stars change when you travel far enough south. For this to happen, you must travel along a curved path. Therefore, the Earth must be round. Aristotle was introduced the idea of the Earth moving around the sun by the Greeks. They could not prove this since the star's position in the sky should shift. They did not assume the stars were far enough away for that this was immeasurable, but rather that the Earth was stationary. The shift of objects from the motion of the observer is called a parallax. This is what the ancient Greeks were attempting to see to show that the Earth was moving. The shift of the stars we can now observe is called the stellar parallax. The sun is so distant from Earth that all the light rays that strike our planet approach on an essentially parallel path. The more distant the source, the smaller the angle between the rays. For a source infinitely distant, the rays travel along parallel lines. Eratosthenes used these parallel lines to measure the Earth in 200 BC. He used two different locations to discover the angle of the light rays. Since they were approximately parallel to Earth, because the stars are so far, the angle the shadow made was a result of Earth's curvature. He used the distance from both cities and the angle of the shadow in order to find the circumference of Earth. He reported the measurement in an ancient Greek unit of stadia. There are discrepancies on which measure of stadia that he used. Depending on which, he was within 1 to 20% off from the modern measurements. Hipparchus built his own observatory to measure the objects in the night sky. He catalogued 850 stars and designated coordinates to each. The stars were catalogued magnitudes based by their brightness. When comparing his findings to older discoveries, he found that the sky on the North Celestial Pole altered over 150 years. He concluded that the direction around which the sky appears to rotate changes. This is due to Earth's wobble, or precession. The Earth wobbles because it bulges at the equator and is not a perfect sphere. The forces from the sun and moon cause it to wobble. Ptolemy was the last great astronomer of the Roman era. His most important contribution was his geometric representation of the solar system. He used his own data as well as old data to construct his model. Placing Earth as a stationary object, the wandering stars had a peculiar motion. The motion he observed occurred from the Earth moving, as well as from the planets moving. However, he attributed the motion entirely to the movement of the planets. Picture a race. As your opponent passes you, they seem to move backwards for a short time. As the Earth speeds up around the Sun, it makes the planets seem to move backward to their usual motion. This is called retrograde motion. This model of Earth as a stationary center which forced apparent retrograde motion endured more than 1,000 years. Ancient Greeks believed that everything moved in circles, rather than ellipses. Ptolemy was limited by these circles. His model was forced to include dozens of circles, some which moved about one another. When the king of the castle was presented this model, he said, "If the Lord Almighty had consulted me before embarking upon creation, I should have recommended something simpler." The motion of the planets were circles, which then also circled Earth. The orbit the planets took was called an epicycle. The larger circle they appeared to move around the Earth was called a deferent. This model was a complicated way to explain the motion of the planets due to the limitations at the time. The next section of this chapter is astrology and astronomy. Ancient cultures believed the stars in the heavens to be symbols of their religion. Ancient Greeks gave each planet the name of a god and denoted them with the same power of said god. They believed that when someone was born and the position of the planets in the sky would affect their personality. They called this their horoscope and denoted a sign to the person based on one of the 12 sections of the sky. The 12 zodiac signs are shown here. Today, some people still practice astrology. However, we know more about physics and the planets today. The planets exert no force significant enough to affect our lives when we are born. Astrologers today argue that there must be unknown forces then. Most people who practice astrology today believe that our personality is determined by our sign, but not our future. The next section we will cover is the birth of modern astronomy. Copernicus was the person who first developed a heliocentric or sun-centric view of the universe. His work was not accepted until 100 years after his death. He turned the tide of cosmological thought and laid the foundation for Galileo and Kepler. Copernicus was not able to prove that the Earth revolved around the sun. However, there was not a way to prove that the sun revolved around the Earth. Religion caused his theory to have no weight for a century. Despite being limited by the assumptions of purely circular motion, Copernicus was able to work out a general model of our solar system. From the Earth, we were able to observe the phases of Venus. If Venus circled Earth instead of the sun, we would not be able to see the phases. This is one of the many pieces of evidence we have today to show that the planets, including Earth, revolve around the sun. Galileo was a big advocate for experiment-based science. His discoveries challenged the ideas of the beliefs at the time and changed astronomy forever. Galileo presented the idea of one of Newton's laws. An object in motion will stay in motion unless acted on by an outside force. He discovered that all objects experience the same acceleration due to gravity regardless of their weight. Galileo and his telescope were the beginning of a change in astronomical thinking. He invented a telescope with 9 times magnification. He turned his telescope to the sky and realized how useful this could be. He then invented a new telescope with 30 times magnification. With this, he was able to discover the moons of Jupiter. He discovered that some individual lights to the naked eye were actually groups of stars. He could now observe the phases of Venus we discussed. This was enough proof to show that the heliocentric model held weight. This wooden telescope is one of the most important inventions in astronomical history. Galileo provided nearly irrefutable evidence for Copernicus's model. He faced initial opposition, but Earth was eventually dethroned as the center of the universe. People struggled with the idea of Earth not being the center of the universe. 4 centuries ago, this idea was terrifying to some people. However, to others, this was stimulating. A new path towards science and technology was being forged.